Hey Bobcats, this is Mr. Peterson. Welcome to another video in this series of already awesome videos about rational functions. Today we'll talk about simplifying and multiplying rational functions, and that should be your goal by the end of the video to do those two things. First of all, let's pause the video, write this definition down. You're probably already familiar. We know what a rational number is. It's a number that can be written as the ratio of two integers. So a rational expression is an expression that involves the division of two polynomials. And we've been talking a lot about inverse variation. In our inverse variation equation, y equals k over x, the k over x part is a rational expression. So here's our first example. They want us to simplify and identify any values for x for which the expression would be undefined. All right, let's start off with the simplification part. We have 3 times x to the 7th over 2 times x to the 4th. Well, the 3 and the 2 don't have any simplification, but remembering our laws of exponents, we know that x to the 7th over x to the 4th is really x to the 7th take away 4. So this is 3 over 2 times x cubed. Alright, now going back to the start, they wanted us to figure out what values would make this expression be undefined. Remember, if we divide by 0, that makes an expression undefined. So if we come back up here to the first initial expression that we started with, if we plug a 0 in there for x, that would make the denominator wind up being 0. So this is undefined when x is equal to 0. Sometimes there'll be more than one answer, sometimes they will only be one. Alright, let's look at part B here. Part B, they want us to, I'll move this up, they want us to simplify and again, decide what values would make this be undefined. Alright, so we have two trinomials there. We need to factor them. If we factor the numerator, we need to find numbers that multiply to 3 but would add up to a -2. So that would be, we would have an x here and an x here. It would be a 1 times a 3. So we have a 3 and a 1. The 3 is going to have to be negative, the 1 is going to have to be positive. Alright, now I do the same thing in the denominator. We got to factor that. We need to find numbers that would multiply to 4 but then would add to 5. And that would be 1 and 4. And since it's all positive, we're just going to be adding. And now that we've factored it, we can see that we have an x plus 1 here and an x plus 1 here, so they will cancel each other out, meaning that the simplified expression is x take away 3 over x plus 4. Alright, now they also want us to decide what values would make this be undefined. Alright, and to do that we need to go back to the factored expression. So if we go back to our factored expression, we need to figure out what would make this be 0. Actually, let me switch colors here to make it a little clearer. What would make this be 0, and what would make this be 0? Alright, so if we think about this, x plus 1 equals 0. Well, if I take away 1 from both sides, I get x equals -1. So this function right there is undefined when x equals -1. And then over here we do the same thing, x plus 4 equals 0. Take away 4, take away 4. This is also undefined when x is -4. So that's the second part to our answer. It's undefined when x is -1 or -4. Alright, why don't you guys, these are going to be broken up into two parts. The first one is simplify. Try that one. And the second part is, when will this be undefined? Okay, here's another one, simplify. And then here's the same one, when will it be undefined? Alright, example 2. Factoring out a -1, which is surprisingly important. If we look at our expression here, well, first of all, the instructions say to simplify 2x minus x squared over x squared minus x minus 2, and identify any values for which the the function will be undefined. All right, so, oh wait, hold up. I think this is left over from the last video. I'm going to take that off. So if you look in the numerator, it's not written in descending order. It's written 2x minus x squared. In descending order, it should be x squared minus 2x. All right, so, but let's look at what happens when we write it like that. So first of all, we know that 2x minus x squared, I'm just going to do a little mini problem first. Another way to rewrite this would be to say plus a negative. All right, so to write this in an equivalent manner, this would be the opposite of x squared plus 2x. All right, so we haven't changed the expression. Remember, addition is commutative. When we rewrite as addition, we can move the order around. But we don't necessarily want to have this leading -1 as a value. So what you'll see, is that we can factor out this -1. So what I'm going to go ahead and do right now is I'm going to go ahead and rewrite the expression with this as my numerator. So negative x squared plus 2x, all of that over the original denominator, which was x squared, take away x minus 2. All right, so what we're going to do is we're going to factor out a -1 from this expression, -1, and I'm going to do this in baby steps. So normally I wouldn't do it in this many steps. So we have an x squared, and then to get this to be back to a positive 2x, I'd have to write it as -2x in there. All right, over, and now we might want to go ahead and try to start factoring the denominator. We want numbers that will multiply to give us 2, but that would add a -1, that would be 1 and 2. Since we need a negative x, then 2 is going to have to be negative, and the 1 is going to have to be positive. All right, but we still have a binomial in our numerator, so we're going to try to factor that out as well. So we're going to have a -1, and both of them have a common x, so we can factor out an x from them, and that would leave us with an x minus 2, and now it should be clear why we were doing all these little steps, because now we have an x minus 2 in the numerator and in the denominator. Well, wrong symbol. So now we can factor out and cancel out the x minus 2 and then re-multiply. We have a -1 times x, which would be -x over the quantity of x plus 1, and that's our simplified form. No more factoring is possible. Now we want to know what values would make this undefined. Same thing, like divided by 0 is undefined, so we want to come back here to this step right here and say what would make these be 0. And so if x was 2, that would make this be 0, and if x was -1, that would make this part be 0. So we are undefined when x is positive 2 and when x is -1. Alright, so those are our two answers there. So why don't you guys try this one? And let me know, when is it undefined? Same expression, when is it undefined? Alright, last example today, you might want to write this down. We are factoring rational expressions. What we want to do, multiplying rational expressions. When we multiply rational expressions, we want to factor the numerator and denominator completely. We want to divide out any common factors. We want to multiply the numerators, then multiply the denominators, and then be sure the numerator and the denominators don't have any other common factors other than 1. So a lot of the stuff that we were using to simplify is still going to be relevant here. Alright, so multiply these two expressions. Alright, so when we multiply fractions, we multiply the numerators, then we multiply the denominators, and then we're going to see what we can do. Alright, so we have 2 times 15, those are our coefficients, that would be 30. Remember, when we multiply exponents with the same base, we just add their exponents, so x to the 4th times x to the 2nd would be x to the 6th. and there's no y to the fifth, so we're just going to say y to the fifth over, let's do the coefficients, 3 times 8 is 24. X to the second times x third would be x to the fifth times y squared. All right, now let's go ahead and simplify. We should notice that 30 and 24 will have common factors. They'll each have a 6. So 6 goes into 35 times, and it goes into 24 4 times. X to the 6th and x to the 5th, that would be 6 minus 5, which is x to the first power. And then y to the 5th over y squared, that would be y to the third power. So there's our finished expression. 5 times x times y cubed over 4. All right, example B, same thing. A little bit harder here because we've got factored form, so we're going to need to be foiling. So in our numerator, we're so let's do some factoring here. So we have, okay, so let's start this thing. I want to take it back a step. I think I said factoring a second, or foiling, and I meant to say factoring. So let's do some factoring. We have in our numerator over here x plus 2, and that won't simplify. But we can factor a 3 out of the denominator, which would be 3 times x plus 4. All right, and then times, over here you'll see why we did that, because we have another x plus 4 right there. And then x squared minus 4, that's a difference of 2 squares. So that's x plus 2, x minus 2. All right, and now we can factor out, or we can cancel out some things. We can cancel out the x plus 2, x plus 2, x plus 4, x plus 4. And I want to point out that when we do that canceling out, we're left with 1s, just to make it clear what's about to happen. So now we multiply across. We have a 1 in our numerator, and then we would have 3 times the quantity of x minus 2 in the denominator, and we want to go ahead, and so this could be considered the correct form, or you could also distribute out that 3. We would get 3x take away 6. So those are the two, and that is the answer for this one. Why don't you guys try this and this? We'll see you in class.